Hey everyone, welcome back. In this video, we are going to review completing the square as a technique of integration. So first, let's talk about when to use this strategy. So first of all, we do, of course, want to have a quadratic, right, which is something with an x squared term. Usually this is going to be in the denominator. And usually after we complete the square with this technique, we're going to have to use u substitution, which we covered in a previous video. And then also, you're usually going to have to use one of your inverse trig integral rules. All right, so let's go ahead and jump into a question to see what that could look like. So if we are trying to take the integral of 1 over x squared plus 2x plus 5, I'm recognizing that this is a good candidate for completing the square as a technique. So first things first, let's go ahead and do that. Feel free to skip to the next chapter if you remember how to complete the square, but otherwise I'm going to write it out now. So if we have x squared plus 2x plus 5, I'm going to set this equal to 0. I'm just doing this as a technique because most of my students see these problems this way and are used to doing it this way. But just note that this is optional, setting it equal to 0. So now I'm going to go ahead and subtract the 5 from both sides. So I'm going to get x squared plus 2x plus blank equals negative 5 plus blank. Again, I like to write it that way so that I don't forget to add something to both sides. So now I'm going to do b over 2 squared. This is my b value here. So in this case, my b is 2. 2 divided by 2 is 1. 1 squared is also 1. So I'm going to plug in 1 there and 1 there. Now I'm going to go ahead and factor my left side. This is going to be a perfect square trinomial. It has to be. That is the entire point of completing the square. So after I factor that, I'm going to go ahead and get x plus 1 squared equals, and now negative 5 plus 1 equals negative 4. Now I'm going to go ahead and add the 4 back over to the other side. So then I get x plus 1 squared plus 4 equals 0. And again, just a quick note, that equals 0 is completely optional and is kind of just my technique for most of my students here. So, but all of that to say, we've now found that x squared plus 2x plus 5 is equal to x plus 1 squared plus 4 by completing the square. Now we're going to go ahead and proceed with the integral. So as I hinted to earlier, we are going to have to use u substitution because we have a composite function here. We have x plus 1 within the greater function. It's in parentheses and it's being squared. So u is going to equal x plus 1. I'm going to go ahead and take the derivative of both sides of that, and I'm going to get du equals dx. And of course, the derivative of 1 is just 0. So that's how I get just du equals dx. So now we are going to go ahead and rewrite the integral. So now I would get the integral of 1 over u squared plus 4 du. So now this is where my inverse trig formulas are going to come in really handy. I'm going to do a separate video on these, so I'm not going to go too much in depth into it now, but I am just going to highlight very quickly that in this case, we are going to have to use this one here because I'm noting on my problem, I have this sum of squares here on the left side. So that's just to let you know where I got this formula and it doesn't feel so much like it came out of left field. So now this, I'm sorry, that's a 4. I know it looks a little messy, but basically here I have u squared plus 2 squared. I'm writing it that way because of the formula, right? So this is telling me that my a is equal to 2. So that's how I got this here. That's how I got 1/2 arctan of u over 2 plus c. And then my final step in this problem, now that I've actually taken the integral, is to go ahead and just substitute back x plus 1 in for u, and then I get my final answer there, which is 1/2 arctan of x plus 1 over 2 plus c. All right, thanks so much for watching, and I'll see you in the next one.